Hi there, welcome to ScholarEd. Today we will be discussing a physics chapter named Light Reflection and Refraction. So let's get started. What is reflection of light? When a light ray traveling in a certain medium falls on the surface of another medium, a part of it bounces back to the same medium in which it was produced. This is known as reflection of light. The reflection of light has certain terms. The ray which falls on the surface is known as the incident ray. This one. The ray which bounces back from the surface is known as the reflected ray. That is this one. The perpendicular drawn on the surface from which the light bounces back is known as normal. The angle between the incident ray and the normal is known as the angle of incidence, angle I. The angle between the reflected ray and the normal is known as angle of reflection, angle R. Now, there are some laws of reflection. There are two laws of reflection. The angle of incidence, which is equals the angle of reflection, that is angle I is always equals to angle R. The other law is the incident ray, the normal to the point of incidence, and the reflected ray all must lie in the same plane. Now, what are the types of reflection? There are two types of reflection. 1. Regular or specular reflection. 2. Diffuse reflection. Regular reflection is the reflection of light from polished surfaces, for example, mirror. The parallel light rays after reflection from these polished surfaces always remain parallel. Take for instance of this diagram. Second one, diffuse reflection. The reflection of light from rough surfaces, for example, chair. The light rays after reflection do not remain parallel. Now, spherical mirrors. So what is a spherical mirror? A reflecting surface which is a part of a sphere is called a spherical mirror. There are two types of spherical mirrors. 1. Concave mirror. 2. Convex mirror. Concave mirrors. Spherical mirrors whose reflecting surface is carved inwards, that is, towards the center of the sphere. That is this one in the diagram. Now, convex mirror. Spherical mirror whose reflecting surface is carved outwards. That is the second one in the diagram. Now, terms related to spherical mirrors. Center of curvature. The center of curvature of a mirror is the center of the sphere of which the mirror is a part. That is represented by C. Now, radius of curvature. It is the radius of the sphere of which the mirror is a part, represented by symbol R. The next one is the pole. It is the geometric center of the spherical surface of mirror, represented by symbol P. That is this pole P. Principal axis. It is the straight line joining the pole of the mirror to its center of curvature. That is this line. Now, focus and focal length. Focus of a concave mirror. It is a point on the principal axis through which the light rays incident parallel to the principal axis pass after reflection from the spherical mirror. It is represented by the symbol F. Focus of a convex mirror. It is a point on the principal axis from which the light rays incident parallel to the principal axis appears to come after reflection from the spherical mirror. It is represented by symbol F. Now, the focal length. The distance between the focus and the pole of the mirror is called focal length, that is small f. There is a relationship between the radius of curvature r and the focal length small f, that is r is always equals to 2f. Now, convenient rays for the construction of image by ray diagram. In order to locate the position and nature of the image, we consider at least two ray incident on the mirror from the same point of the object. Any two of the following rays are taken as the convenient incident rays. Number 1. A ray passing through or directed towards the center of curvature of a spherical mirror is reflected back along its own path. That is, when an incident ray passes from the center of curvature towards the spherical mirror, it is always reflected ray is always passed through the center of curvature of the same spherical mirror in the same direction for both the cases of concave and convex mirrors. Number 2. A ray incident parallel to the principal axis after reflection either passes or appears to be coming from focus. That is, when a light ray, that is an incident ray, falls on the reflecting surface of the spherical mirror, it tends to be coming from the focus or passes through the focus for both the cases of concave and convex mirrors. Next, a ray passing through the focus or converging at the focus after reflection becomes parallel to the principal axis. When a light ray passes through the focus and falls on the concave mirror, it is always reflected back parallel to the principal axis in both the cases its mirrors. A ray incident at the pole is reflected in such a way that the reflected ray is at an angle of reflection equal to the angle of incidence with the principal axis as normal. When an incident ray strikes the pole, is always reflected back at the same angle of incidence, that is, angle of I will always remain equals to angle of R when the light ray strikes at pole. For both the cases in concave and convex mirrors. Now, the image formation by a concave mirror for different position of the object. So, the position of the object, we will be putting the object at different places and we will take a look of the position of the image formed and the size of the image and the nature of the image. First, at infinity, the position of the image will be formed at the focus. The size of the image will be highly diminished to a point, and the nature of the image will be real and inverted. Let's see the diagram. Number 1, that is, the object is at infinity. When the object is at infinity, the light rays coming from it is always parallel to the principal axis, and due to which all the lights will directly pass through the focus, forming the image at the focus, which is very small, diminished, and it is real, and it is also inverted. Number 2, beyond the center of curvature. The position of the image will be formed between the center of curvature and focus. The size of the image will be diminished, and the nature of the image will be real and inverted. This is the diagram for it. Object beyond the center of curvature. The image is formed just between the focus and the center of curvature, which is diminished, real, and it is inverted. Now, the next one is object at the center of curvature. When the object is placed at the center of curvature, the image formed is same at the center of curvature. That is this one. But it will be of same size and real and inverted. The next one, that is, when the object between the center of curvature and focus. When the object is placed between the center of curvature and focus, the image that is formed is beyond center of curvature, and the size of the image becomes magnified, and the nature of the image is real and inverted. Now, when the position of the object is at focus, the position of the image is at infinity. Then the size of the image will be obviously highly magnified, and the nature of the image will be real and inverted. This is the diagram for that. The object is at focus, and the image formed is at infinity, which is highly magnified, and it is also real and inverted. Now, if the position of the object is between the focus and the pole, then the position of the image is at the back of the mirror. Yes, you have heard right. The image that is formed will be at the back side of the mirror, which will be erect and virtual, and will also be a magnified image. Now, the image formation by a convex mirror for different position of the object. So let's take a look. When the position of the object is at infinity, then the position of the image will be at focus. For this diagram, it's given below. Light rays are coming from infinity, due to which they are parallel to the principal axis, and hence the image that is formed is at the back side of the mirror at focus, which is diminished to a point, and the nature of the image will be virtual and upright. Similarly, when the position of the object is between infinity and the pole of the mirror, the position of the image will be formed between focus and pole, and the size of the image will be diminished. This is the image formed at the backside of the mirror, which is virtual and upright. Now, let's see some uses of concave mirror. As a shaving mirror to use that we use in real life, in everyday, we see a magnified image of our face. As a reflector in torch, searchlights, headlight of automobiles, cars and cycle, etc. to obtain a parallel beam so that we can see over a long distance. It is also used as a dentist's head mirror. And large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. Some uses of convex mirrors are as a reflector in street lamps and as a rear view mirror for wider field of view in automobiles, as they give an erect though diminished image. So what is the difference between concave and convex mirror? A concave mirror is made by silvering the outer surface of a part of hollow sphere, whereas in convex mirror it is made by silvering the inner surface of a part of hollow sphere. Concave mirror reflection takes place from the inner surface, whereas in convex mirror reflection takes place from the outer surface. In concave mirror, converges light rays incident on it after reflection, whereas in convex mirrors, diverges light rays incident on it after reflection. In concave mirror, it forms both real and virtual image depending on the position of the object, whereas in convex mirrors, forms only virtual image. There is no real image formed in case of convex mirrors. In concave mirror, the image is diminished of same size as object or magnified depending on the position of the object, whereas in convex mirror, image is always diminished. So this will be the end of this chapter. We will be studying refraction in the next part. Till then, subscribe to our channel and stay tuned. Thank you.